Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of finding the three largest numbers in an array of numbers. This is a fairly straightforward question. You're given an array of numbers, of integer values. The array is not necessarily sorted. It could be sorted, but you're not told anything about the order of the numbers, so it could be completely out of whack. Like in the example that I've got in front of me here, this array is definitely not sorted. And you are tasked with finding the three largest numbers in this array. And you want to return a sorted array of these three largest numbers. So in this example that I've got in front of me, the answer is going to be this purple array here with the number 18, followed by 141, and finally 541. So how do we solve this question? Well, it's pretty simple. You're basically going to want to store and keep track. So keep track and store of the three largest numbers as you go through the array. So you start traversing the array at the very beginning at number 141, and slowly but surely as you traverse the entire array, you continuously store and keep track of and update the three largest numbers up until the number that you're at. So we're going to declare an empty array of length 3 here, where we're going to have the third smallest number, the second smallest, or the third largest number, the second largest number, and the first largest number. And we're going to update them as we go. So we start traversing the array at the number 141. And we check if first we check the largest number in the array, in our final array, which is the third number here. And we check if we even have a number. Because we don't have a number, like we've just got this hyphen here representing nothing, then we can just update it. That just tells us that we have no largest number. Let's just update it. So we can erase this hyphen and put 141. Then we move on to the second number, the number 1, and we compare it to the largest number that we have. Is the largest number, do we even have a largest number? Yes, we do. We've got the number 141. Is 1 greater than 141? No, it's not. So now we compare it to the second largest number. We've got a hyphen here, so we don't have a second largest number. So we can update it to be 1. So we can put 1 here. And then we've got the third number in the array, which is 17. So we're going to compare 17 to the largest number that we have. 17 is smaller than 141. So we compare it to the second largest number that we have. And here, 17 is greater than 1. So what we're going to do is we're going to shift, no matter what we had here in this third largest number. Here it turns out we didn't have anything in the third largest number. But no matter what we had here, we're going to shift this out and shift this number 1 to the left. So we're going to grab whatever third number we have, shift it out, and we are effectively getting rid of it, so we can erase whatever it was. And then we grab our second largest number and shifted 1 to the left and put 17 here in the middle. Because, again, just to make sure that we're on the same page, 17 was greater than our current second largest number, which was 1. Therefore, we want to make 1 our third largest number and 17 our second largest number now, our new second largest number. So then we get to minus 7. So we compare minus 7 to 141. It's definitely smaller. Compare minus 7 to 17. It's smaller. Compare minus 7 to 1. It's smaller. So negative 7 is not one of our three largest numbers. Do the same thing with negative 17. It's smaller than 141, smaller than 17, smaller than 1. Don't do anything. Same thing for negative 27. It's going to be smaller than all of them. And then we get to 18. 18 is smaller than 141, but it's greater than 17. So we're going to apply the same logic that we did earlier, which is we shift the third number out, and we effectively erase it. Then we shift the second number to the left 1. 17 becomes our third largest number. And we update the new second largest number to be 18. And now we continue traversing our array. We get to 541. 541 is greater than 141. It's greater than our largest number. So we apply this logic, this entire logic of shifting once again. We grab the third number, 17, shift it out and get rid of it, erase it. Grab 18, move it to the left. Grab 141, move it to the left. And grab 541 and put it here as the new greatest number. And now I'm not going to go through the rest of the example. You can kind of see for yourself immediately that 8, 7, and 7 are smaller than all three of our greatest numbers. And we're done. Now we've got our final array. It's already sorted. We know that these are the three greatest numbers, and we are happy that we found them. In terms of time and space complexity, the time complexity of this algorithm is going to be equal to O of n, where n is the length of our input array. The reason it's O of n is because we have to traverse the entire array, right? We're told nothing about the array. It could be completely unsorted, which it is in this case. So we have to explore it entirely if we want to find these three greatest numbers. And so our time complexity is O of n. Also, at each number in the array, when we compare the number to the current greatest numbers that we have, we've got a finite amount of computations that we have to make. We just have to do a few comparisons, and if the number happens to belong in the three greatest numbers, we just do a few shifts, but these are all kind of constant time operations because we know that they're bounded by like 3 or 4 operations in total. So our time complexity is O of n. Our space complexity is going to be O of 1, so constant space, O of 1. And this is because we're not using any additional memory, at least not proportional to our input or the size of our input. All we're doing is storing these three numbers here in our final array, and that's just constant space. So that's it for this algorithm. Let's implement it in code now. All right, so we've got our find three largest numbers function defined, and it takes in an array in no particular order. The numbers in the array are not necessarily sorted. And the first thing we're going to want to do is initialize the final array that we're going to return that's going to contain the three largest numbers. So 3 largest is going to be an array of length 3, and we can initialize it to hold just the none values. Here you can talk with your interviewer how you want to initialize this array. I'm just going to initialize it with the none or null values. And now we're going to start traversing our entire array and updating our 3 largest accordingly. So for num in array, for every number in the array, we're going to call a helper method to kind of abstract this updating logic out of this main function. And we're going to call update largest, passing in the 3 largest array and passing in our number. And once we're done with this for loop, we can just return the 3 largest, because presumably once we've traversed the entire array, calling this update largest function, then our 3 largest array is going to be final and we can return it. So now we want to define this update largest method, which is going to take in our 3 largest array as well as our number. And the first thing we want to do is compare the current number to the third value in our 3 largest array, which represents the largest number in our 3 largest numbers. And so we want to say if 3 largest at index 2 is none, in other words, if we don't have a number there yet, or num, our current number, is greater than 3 largest of 2, then we want to update this final value. And here, once again, we're going to abstract this logic of updating the value out of this function and into a helper method, because if you recall during the conceptual overview, when we update this 3 largest array, we might have to shift some numbers to the left, right? And so because of that, it's better or it's cleaner to abstract this logic out. And so I'm going to call a helper method here that I'm going to call shift and update. and I'm going to pass in arguments in a second when we define it. So for now, I'll just add a to-do here. So then if neither of these conditions are met, in other words, we have a number here in the third value, but it's bigger than our current number, then we want to compare our current number to the second largest number. So we're going to say elif 3 largest of 1 is none, or num is greater than 3 largest of 1. Then call this shift and update method again, and we're not going to pass in arguments just yet. And finally, elif 3 largest of 0 is none, or num is greater than 3 largest of 0. Then we shift and update, and again, to do. So basically what this update largest method does is it checks one by one, starting with the largest, then the second largest, then the third largest, if these numbers are none, or if our current number is greater than these numbers. And depending on if some of these conditions get met, we call this shift and update method. Now let's look at the shift and update method. So shift and update. What is it going to take in as arguments? Well, it's going to take in our array, right? Our array, the 3 largest array, so we can just call this array. It's going to take in our number, the number that we want to insert or update into this array. And then what we can do is we can pass in an index. And this index is basically going to be the last index in our array of 3 numbers that we want to shift or that we want to update. Okay? And so in other words, if we are updating the third largest number, we don't want to touch index 1 or index 2, right? We just want to update the third largest number. Conversely, if we're updating the largest number, then we want to not only shift the first index to the 0th index, but we also want to shift the second index to the first index and then update this largest number. So by passing in an index, we can kind of do this dynamically and very cleanly. We can say for I in range index plus 1. Remember that Python ranges are exclusive, so index plus 1 here is exclusive. So we're going from 0 to idx. If I is equal to index, in other words, if we are at a point in our iteration where we are at the last index, the index that we passed into our method, then we just want to update array of I to be equal to our number, the number that we wanted to put. Otherwise, else, array of I is going to be equal to array of I plus 1. So let's say that we had passed in index 2, okay? We would have an array here with, let's say, x, y, and z, and this array would be represented by the indices 0, 1, 2, and let's assume that idx was 2. Then we would say for I in range from 0 all the way to 2 plus 1, where the plus 1 here is kind of excluded of the range. And then if I is equal to 2, then we update this z here to be our number, right? Otherwise, for all the numbers or for all the indices before 2, we update array I to be equal to array I plus 1. So here at x, we've got index 0. So x is going to be equal to the array at index 1. So it's going to be y. Y is going to be z. And then z is going to be num. So this diagram here kind of shows you how this algorithm works. And now we are done with it. We've finished implementing it. The last thing that we want to do is pass in arguments here. So here we're going to pass in largest or 3 largest, our 3 largest array, num and index 2, because we're shifting and updating all the way to index 2. Then here we're going to pass in 3 largest num and index 1. And finally here we're going to pass in 3 largest num and index 0. Now we can delete these to-dos and simply add the space and time complexities. So this algorithm is going to run in O of n time and O of 1 space. Because we have to traverse the entire array, we're doing constant time operations at every point in the array, and we're not storing anything but these 3 largest numbers, which don't take much space at all. That's it for this video. I hope it was helpful. I'll see you in the next one.